Today's lesson is on surface area of regular right pyramids and cones. A regular right pyramid is a pyramid where the base is a regular polygon. All regular pyramids also have a slant height, which is the height of the lateral face. In a right pyramid, the lateral faces connect the base polygon to a vertex that is perpendicular to the base. The lateral surface of a cone connects the circle base to a vertex that is perpendicular to a base. If I draw this square pyramid as a net, I can see that I have a square base, and I can separate out the four triangles that make the lateral face like this. If you notice, the 12.6 is the height of one of the triangles, but that also means it's the height of all of the triangles. The sides of this base are 8 feet and 8 feet, and the slant height is 12.6. So let's use the net of the square pyramid to figure out a formula that can work for all. So you notice again, we have a square base and four triangles that are identical. That means I have one B, and this base shape, if we consider what we did with prisms, so let me scratch this out. This should actually say pyramids. If we look at our base shape, we used to take this into consideration, which is the perimeter of the base shape. And that perimeter of the base shape does correspond to all of the triangles at their base. Each one of those triangles is 1/2 base times height to determine their area. But instead of doing each one separately, we can do 1/2 of the perimeter times their height. But for height, we actually use the slant height, meaning this number. The slant height is given by the variable L as a cursive. It's a cursive L because it's slanted. So we can take the area of the base shape and add it to the lateral surface. The lateral face is made up of all of the triangles, and the lateral face can be written 1/2 perimeter of the base shape times the slant height. So let's evaluate that with the values that we have here. The area of the base shape would be the base times the height of the square, or 8 times 8, which is 64. The lateral face, which is 1/2 of the perimeter times the slant height, I can say it's 1/2. The perimeter is 8 times 4. 8 times 4 is 32, and the slant height is 12.6. Now we can use our calculator. You get the value of 201.6. That's for all the triangles together, or the entire lateral face. My last step is to add 64 plus 201.6, which equals 265.6 feet squared. Let's practice this again, looking at this shape. This shape is a triangular pyramid. Notice that it's only made up of triangles. It's got a lot of different lines that look like slant heights, but some of them are just the height of the base, and some of them are the height of the sides. So let's decide which shape is the base. I notice, again, I want to work with regular shapes. I've got 12, 12, and 12 on the triangle that is the base shape. So my surface area is the base shape plus 1/2 of the perimeter of the base times the slant height. The base shape is made up of 12s. Each side, the perimeter, would be 36, or 12 times 3. In order to find the area of the base shape is a triangle, so I need 1/2 base times height. In this case, it's 1/2. The base of my base triangle is 12, and the height of this particular triangle is the line that extends across the bottom from the side of the triangle to its vertex on the opposite side. and that's given by the number 10.4. We can multiply that together. Half of 12 times 10.4. That results in a value of 62.4. The last thing I need to determine is my slant height. The slant height is the height of the triangle pyramid that goes from the apex down to the side of the base. So my slant height is 7.8. I'm going to take these values and substitute them in where they belong. So the area of my base shape was 62.4. I have half of the perimeter times the slant height. I need to make sure that I continue to do my work using order of operations, so I have to multiply 1/2 perimeter times slant height first, which is 140 and 4/10. Then I can add it to 62 and 4/10. 202 and 8/10 yards squared. Let's try this with a regular polygon that is a pentagon base. Again, the surface area is one base shape plus 1/2 of the perimeter of the base shape times the slant height. So I have three variables that I need to determine: the slant height, the perimeter of the base shape, and the area of the base shape. Again, we're working with regular polygons. So the perimeter would be one side of my polygon. In this case, it's a pentagon times 5. So my perimeter is 5. For the slant height of the shape is the point from the vertex down to the side of the base shape. So the slant height of this particular shape is 12.1. The last piece I need is the area of the base. Don't forget, the area of a regular polygon is 1/2 of the perimeter of that polygon times its apothem. So I have 0.5. We already know the perimeter because we've determined the perimeter of the base shape. And the apothem is given to us as 6.9. So the last thing we do here is take the 50 times 1/2 times 6.9 to determine that the area of the base shape is 172.5. Now that I have all of my variables identified, I can substitute the values into the formula for surface area of a pyramid. Now I would calculate using the order of operations. My result is 475 feet squared. So let's look at how that works for a cone. For a cone, instead of using the perimeter, we have to use the circumference. Otherwise, we still have one base shape, and we still have something that looks somewhat like a triangle. It works just like a pyramid does, so we can write the area of the base shape plus 1/2 of the circumference times the slant height. Note what I've written here. Half of a diameter is a radius, so half of the circumference is really pi times the radius. So for a cone, you can rewrite this as the area of a circle, because that's the base shape, plus pi times the radius times the slant height. If we leave this in terms of pi, the only variables you need are the radius and the slant height. So the radius for this shape is 11, and the radius and the slant height for this cone is 24.6. I'm going to rewrite this as pi times the radius squared plus pi times the radius times the slant height. Make sure that when you're done doing your multiplication, you leave pi at the end, similar to a variable. So in this case, I would have 121 pi, and in this case, I have 270.6 pi. Now, because both values have pi with them and are multiplied by pi, we can actually add 270.6 and 121, and we end up with 391.6 pi feet squared. We would not have been able to add them together if one of the values did not include pi. We're going to look at how the formula works. Again, the surface area of a pyramid is the area of the base shape plus the lateral faces, or the area of the base shape times 1/2 perimeter times the slant height. For a cone, it's still the area of the base shape and the lateral face But in this case, the base shape area is pi times the radius squared. Half of the circumference would equal pi times the radius. So we're going to practice 4 of these. I'll start with a pentagonal pyramid and we'll go through each of these shapes. Please note that every time you do this, you want to make sure that you're identifying your variables before you start to solve the problem. So the first step would be to write out my surface area formula for a pyramid. I have 3 variables. I need the area of the base shape, I need the perimeter of the base shape, and I need the slant height. The first value that is the easiest to determine would be the slant height. The slant height here is 9.7. Then I can determine the perimeter of the base shape. If you notice on this pentagon, the perimeter is made up of a regular polygon with each side being 8. 8 times 5 is 40. The last part of this is to do the area of the base shape, and the area of the base shape is 1/2 perimeter times apothem. If I want to do 1/2 of the perimeter times the apothem, we already know that the perimeter is 40, and the apothem is given to us as 5.5. It's the line that goes from the side of the polygon to its center. So half of 40 times 5.5, which equals 110. So now that I have all of my values, I can substitute those in. And you notice we get a result of 304 centimeters squared. Let's do number 2. In number 2, our shape is a square pyramid. Base plus 1/2 perimeter times the slant height. My base will be base times height, which equals 9. My perimeter is 3 times 4 because I have each side being 3 yards, so 3 times 4 is 12, and my slant height is 2.5. My result is 24 yards squared. Again, don't forget your units. Units for surface area are always units squared. Number 3, this time I have a cone. In a cone, I have the base times 1/2 of the circumference times the slant height. I can rewrite that as pi r squared plus pi times the radius times the slant height. So the 2 values I need are the radius and the slant height. The radius is 7 and the slant height is 15.7. Which equals 158.9 pi kilometers squared. That is my answer in terms of pi. If I wanted to use 3.14 for pi, I would wait to this step to use 3.14, and I would substitute that value in and make it approximately equal to 5.9 times 3.14, which is about 498.9 kilometers squared. For my last example, we will work with the cone. It's inverted, but I still have the area of the base shape plus 1/2 of the circumference times the slant height. Again, my base shape is a circle, half of the circumference is pi times the radius, and I have the slant height. So I need the radius and the slant height. Be very careful here that you don't use 18. 18 is the diameter, so the radius is 9. This way you equal 261.9 pi kilometers. Again, if you do this times 3.14 as pi, you would have to make it approximately equal to, because 3.14 is an approximation of pi, 822.4 kilometers squared. I look forward to discussing this with you in the next lesson.